welcome to my tutorial on carbonyl compounds and their reactions. We're going to go through back to AS and learn how to name aldehydes and ketones, and all the way through to testing for carbonyl compounds, a new thing that you'll learn in A2. But first, back to basics. So we're going to name aldehydes. Aldehydes are any chemical organic compound with C double bond O and a H group. And to name them, you start by looking for the functional group, like any carbon chain. But the first thing I always notice is how long is a chain. So pent for 5 in this case. And since I know it's an aldehyde, I put an in. And since I've noticed there's a 2-methyl group, I put 2-methyl at the front. So its full name is 2-methyl pentanal, or 2-methyl pentanal. But I put the dashes in to make the prefix clear. Same for this ketone. You look for the double bond O in this one. So we look for the 2-methyl here, pentan because it's 5 carbons, and 3-one just meaning I've got a double bond O group on the carbon 3. So definitions for this part: the functional group is the part of the organic molecule that is responsible for chemical reactions. Electronegativity is a measure of the attraction of electrons between atoms in a covalent bond. The stem is the longest carbon chain in an organic molecule, and a suffix is the part of the name after the stem. So when I say a suffix, an is a suffix, and stem would be pent. Now we are moving on to the questions. Now I'd like you to have a go at drawing these structures: hexane 3-one, butanal, and 2-methyl pentan 3-one, 2-methyl pentan 3-one. And what is the difference in functional groups in these structures? So I'll give you a 5-second pause and we can have a look at the answers. Right, we'll look through the answers now. So for hexane 3-one, we get the double bond O group, and you have 6 carbons, hex meaning 6, and you fill in the rest of the hydrogens there. For butanal, you have the aldehyde group C double bond O H, not OH as in the alcohol. So you have 4 carbon atoms, double bond O H, bang on, nothing else to be done here other than you filling your hydrogens. So for 2-methyl pentan 3-one, you have methyl group at carbon 2, and a ketone group at carbon 3, all filling all the rest with hydrogens. For skeletal formulas for hexane 3-one, you'd go 1, 2, 3, and then you go double bond O, 4, 5, 6. That, so go 1, 2, 3, 4, 5, 6. So it's easy to draw one too many carbon than you need. So using that method may help you when drawing skeletal formulae. So if you go 1, 2, 3, 4, 1, 2, 3, 4, and then you have double bond O here. So I'll put double bond O there. That's butanal. Don't forget the skeletal formulae do not contain any hydrogen atoms, or well, they contain oxygen atoms, but they do not contain any hydrogen atoms. Sometimes if you have a nitro group, they contain nitrogen groups, but not today. I'm not going to go for nitro groups today. So for 2-methyl pentan 3-one, we have 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. So 1, 2, 3, 4, and one more for 5, and we have a double bond O on the 3, and a methyl. I'm just going to use a stick to represent the methyl group. That's your 2-methyl pentan 3-one. Notice how I use the methyl group. The methyl group can go any orientation. Same with the double bonds. Here and here, it doesn't matter. As long as you draw them on the right carbons, you should get the marks in an exam. So now we're going to go through the oxidation of alcohols and aldehydes. So if you oxidize a primary alcohol, you get an aldehyde, and then if you do that again, you get a carboxylic acid. So those basic reactions are summarized here. So you have CH3CH2OH plus the oxidizing agent, which is potassium dichromate, or Kr2CR7O2 minus, and CH3CH2 plus 2 oxidizing agents, which is making the carboxylic acid, you get CH3COOH plus H2O, and you also get CH3CHO plus H2O over that side as well. Sorry, forgot that. And then when you oxidize this with a secondary alcohol, because it's on the second carbon, you get a ketone. So the ketone will be arranged like this, and the equation for that particular one would be CH3CHOH CH3 plus oxidizing agent, and then that goes to CH3 COO CH3 plus H2O. Water group is removed. So that's it for oxidizing aldehydes and alcohols. So now we'll move on to reactions of aldehydes and ketones. So for aldehydes, if you have the aldehyde propanal, you need a reducing agent now, like hydrogen. So the H would be the reducing agent. You don't need to know what the reducing agent is for A2, but you're expected to know that it makes a primary alcohol like this. So again, my foolproof way: 1, 2, 3, count your carbons, OH bond. And for reduction of aldehydes, you get a ketone. So we use pentan 2-ol, H, C, H, C, double bond O, another H, C, H2, and that goes C, H2 again, and then you get CH3. I'm simplifying it for the sake of not having enough space, and then you get 2H, and you will get H, C, H, and then on the second carbon you get an OH group, and the rest is all an alkane molecule with hydrogen atoms. No change really, except for that OH group on group 2. Sorry, carbon 2. So that would be pentan 2-ol, as the alcohol is on carbon 2. Right, now we're going to go through the reactions of aldehydes and ketones. Using hydride ions or negative negative H minus ions with lone pairs, the hydride ion can attack the carbon atom and form a new bond, and the intermediate step is to form an oxygen with a lone pair and a negative charge, so it can bond with a water molecule, and then the organic product formed is an alcohol and an OH minus nucleophile. So this nucleophilic addition is very important, as it's another way to make alcohols from aldehydes and ketones. And the reactant used is NaBH4. So this forms BH4 minus and hydride ions when aqueous. So the hydride ion is our nucleophile. Okay, so chemical tests for carbonyl compounds. Aldehydes and ketones can be detected by adding 2,4-DMP. DMP stands for dinitrophenylhydrazine. So a solution of 2,4-DMP in a mixture of methanol and sulfuric acid is called Brady's reagent. This is used quite often in analysis for aldehydes and ketones. And the precipitate formed is called 2,4-dinitrophenylhydrazone. Tollens reagent is a weak oxidizing agent used to distinguish between aldehydes and ketones. Aldehydes are usually oxidized to carboxylic acids by using Tollens reagent. Ketones are not oxidized by Tollens reagent. The not oxidized is very important, as you can detect only aldehydes. Ketones, nothing happens. To find out what happens with Tollens reagent, I've made a sort of table here. With aldehydes, a silver grey solid precipitate or a silver mirror is formed, and I'll show you what one of those looks like in a bit. Ketones have no reaction because no precipitate forms, but really what you should write in practicals is no observable change. OCR examiners are very fussy about writing what exactly happens in reactions, and if you want to write "oh, nothing happened," then this is examiner speak for "oh, nothing happened." The basic reaction that goes on is this generic one, so a ketone plus an oxidizing agent goes to a carboxylic acid, and there's a procedure you have to remember when identifying carbonyl compounds. I'll quickly go through it. So you identify a carbonyl compound using the following steps. The yellow-orange solid 2,4-nitrophenylhydrazone is slightly impure, so you filter and recrystallize to produce a purified version of the precipitate. Measure the melting point of the purified solid and compare it to databases or data tables. In the textbook there are some data tables to help you with compounds like heptan-2-one and cyclohexanone, but most exam questions ask for the exact steps, and they will give you tables if you need to compare their boiling points and their melting points of the 2,4-DMP derivatives. So, typical exam question would have compound and boiling point in degree C and a melting point of 2,4-DMP. I'll put for derivative. So this is the example for heptane 2-one. So as you can see, boiling point is significantly higher than the melting point, but the boiling point is for the compound, not for the derivative. And that's it for this tutorial. Quick summary of all that we've done in terms of definitions. The functional group is part of the organic molecule responsible for chemical reactions. Electronegativity is a measure of the attraction of electrons between atoms in a covalent bond. And the stem is the longest carbon chain in an organic molecule. This is useful for naming your aldehydes and ketones. And the suffix is part of the name after the stem, useful for naming again. So we went through naming, we went through the different structures and the reaction mechanisms, and how to test for carbonyl compounds, and we went through some questions as well. So I hope you found this useful. Leave a comment in the comment section below if you liked it, or if you want me to do something slightly different, and come back when you want to learn more about OCR A2 chemistry. Thank you and goodbye.